discussed about Pearson correlation coefficient based performance enhancement of broad learning system for stock price prediction. Then we are going to see about the overview of our project, that is abstract. The main objective of our project is to predict or forecast the stock price by using different machine learning algorithms based on our dataset. Accurate prediction of stock market returns is a very challenging task due to volatile and non-linear nature of the financial stock markets. With the introduction of artificial intelligence and increased computational capabilities, programmed methods of prediction have proved to be more efficient in predicting stock prices. The financial data, open, high, low, and close prices of stock, are used for creating new variables which are used as inputs to the model. The models are evaluated using standard strategic indicators, that is RMSE and MAPE. The low values of these two indicators show that the models are efficient in predicting stock closing price. The system is developed the machine learning algorithms such as lasso regression and support vector regression for predicting the stock price. So this is the overview of our project. Now we are going to see about the flow of our project. First we are collect the dataset as input, the dataset name stock dataset, then input data. Here we are select or load the input data by using pandas package. Then the input data are carried out to pre-processing step. Here we have to check missing values and drop unwanted columns. Handling missing values purpose is for avoid wrong prediction. Drop unnecessary columns means if you want any unnecessary columns in your data set, means we have to drop that unnecessary column in priorly. Then the pre-processed data carry out to data splitting module. Here we are splitted your whole data set into test and train. Test is used for prediction, train is used for evaluation. Then feature selection module. Here we are implemented Pearson correlation coefficient. With the help of this we have to correlate the two values, or else we have to select the best features from our pre-processed data. Then classification. Here we are implemented two different machine learning regression algorithms. One is support vector regression, which is already implemented in existing system. Next, lasso regression, which is implemented by proposed. So we are conclude these two algorithm results and compare these two results based on performances. Then performance metrics. So here we are estimate some performance metrics like MAE, MSE, RMSE. These are the error values. Then visualization. Based on error values we can conclude which is efficient or not. Then we have to predict the stock price. So this is the flow of our project. Now we are going to see about our demo of our project. So this is the output of our project. We are running our project in Spider IDE from Anaconda Navigator. So this is the input data. Here we are displayed some sample of input data from your dataset. Then pre-processing. Pre-processing means here we have to check any missing values is present in your dataset. If you have any missing values, means we have to replace that missing values by zeros. Here 0 indicates there is no missing values in corresponding column. Then correlation. So correlation in essence, so this is the feature selection method. So here we are correlate two variables. Then data splitting. Here this is the total number of data which is present in our data set. Then this is the total number of training data. This is the total number of testing data. Then support vector regression and lasso regression. So this is existing algorithm and this is proposed algorithm. So when compared with two algorithms, based on result we can conclude which one is efficient. So MAE, MSC, RMSC value for support vector regression, so they occur like this. Then similarly MAE, MSC, RMSC value for lasso regression. Then prediction, so here we predict stock price. So this is the prediction graph of stock price. This is the comparison graph for SVR and lasso regression. Error value must be low. If the error value is low means the model is efficient. So we conclude lasso regression, that is our proposed model, is efficient when compared with SVR. So this is the output of our project. Thank you.